Okay, so our last synchronous session is about the application of spectrophotometry. Actually, ano lang, no? We're going to discuss yung details ng how does this look like, tapos ano yung mga parts niya. Okay, so yun yung gagawin natin for today. Okay. In your lecture, ano na yung mga na-discuss sa lecture sa chapter 7? Yung types of spectrophotometry, no? Ano yung mga types of spectrophotometry? We have the absorption, we have the emission, and then we have the fluorescence. Okay? So, dadaanan din natin uli yon later. And we know that in absorption spectroscopy, we can quantify matter, no? Based on how much ang na-absorb na light, diba? Okay? So, we use the Beer's law for that. A equals epsilon BC. And yung B ay yung path length. Okay? Mamaya pakita ko ano yung meaning ng path length na yun. Yung C is the concentration and A is the absorbance. Okay? So the absorbance is the ratio of the transmitted and the incident light. Okay? So yan. So, ang gagawin lang natin today is basically, pagsasama-samahin lang uli natin yung mga idea sa lecture. Then, magbibigay tayo ng ng details, how do spectrophotometers work. Okay? So, yun lang gagawin natin. So anyway, this is our topic outline. So we will discuss the components of the spectrophotometers. We will talk about UVVs and the single double beam and the infrared spectrometers. Okay. So before we start now, let's review some terminologies. No? Una, we have the spectroscope. No? Ang meaning ng scope ay titignan mo. Okay. So ibig sabihin para siyang microscope. No? Telescope. No? So if you are using microscope, you are viewing microscopic objects, mga maliliit, no? If you are using telescope, ang tinitignan mo ay mga distant objects. But in spectroscope, what you are observing here are colors, no? Spectrocolor. Okay? So you are observing the colors emitted or radiated by an object. Okay? So, ito ay precursor ng mga modern instrument natin. So, all the modern instrument we use in chemistry are based on spectroscopes. No? Spectroscopes actually date back around 18th century pa, no? Even Newton was able to use this, no? But developments in physics and in chemistry, no, made better apparatus, no? Made better instruments na ginagamit namin today for chemical analysis, no? And gagamitin nyo rin in the future, okay? So, one of the modern version of spectroscope, no, that we use in the laboratory is the colorimeter. So, meter meaning measurement, color meaning color, okay? Ibig sabihin, it is a device that measures the color, okay? So, ganyan yung itsura niya. So, ano ganap dito? Okay, ganito. So, one example of the use of colorimeter is when you do urinalysis, no? Okay, when you do urinalysis test, ganito ginagawa nyo. Let me pull up some data. So, this is the test strip, no? Each cell contains interpretation, okay? So kunwari may certain cell for uric acid, may certain cell for ano pa ba mga components nun? Basta 'yon. May mga each boxes diyan may corresponding na molecules silang nire-represent, okay? So gagawin mo diyan, you will submerge this into the urine sample. So lulublog mo 'yan doon and then magbabago kulay niya. Okay? So, magbabago kulay niyan pag nilublob mo yan doon. And then, what you're going to do next is that you will compare the colors in this color palette, no? So, this is the color palette. Okay? So, for example, this color will tell you kung ano yung zoom in ko nga. Kunwari, this color will tell you yung nitrate content ng urine. Kunwari, this color will tell you the proteins present in the urine. Kapag maraming proteins, ibig sabihin siguro may sira yung kidney mo. Nagli-leak yung proteins doon. Ano pa? Kunwari, this color will tell us the pH of the urine. Kapag masyadong acidic yung urine, ibig sabihin there's something wrong. Baka may mga kidney stones dyan namumuo. Kunwari, this one will tell us the bilirubin, hindi na ako familiar doon. Okay. Hindi na ako familiar sa iba dyan. Basta ganun lang idea. So, ilulublob mo to dyan, and then it will change colors. Then, traditionally, ang ginagawa is, ayan, i-compare mo siya sa color palette. Hanapin mo kung ano yung kakulay niya doon. Okay. But there is a problem with that. Number one, color is subjective. The intensity of color may be different from people to people. Considering also that there are people that are color blind. So, kunwari ikaw medtech, tas ikaw medyo color blind ka, hindi mo ma-interpret na maayos yung results. So, to minimize the errors, we use the colorimeter. Okay? So, gagawin mo, ganun pa rin naman, ilulublob mo yan sa urine, then allow it to change color, and then ipapasok mo siya sa colorimeter. Okay? Let me show you. Ito yung colorimeter na ginagamit doon. So, basically, you have this paper, papasok mo yun doon. Then, it will give you the accurate results. Based on the intensity of color, it can tell you the exact concentration. Okay? So, sasabihin niya, ito yung concentration niyan. Okay? So, ganun yung idea dyan. Okay? Kasi the problem with the traditional method in which we use color palettes is that ano lang makukuha mo dito, ranges. Pero, if you use a colorimeter, you will get much accurate results. That is free from bias ng perception ng eye natin. Okay? So, that's colorimeter. Okay? So, yan. So, yan yung isang application ng topic na to sa field news. That's why this is important. Another thing we use in the laboratory are called the photometers. So, meter, measuring device. Yeah. Photo, meaning it has something to do with light. So, these photometers or spectrophotometers, these are instruments we use to tell kung ano yung relationship ng light with the matter. So, sinasabi niya sa atin, kunwari, mataas yung absorbance niya, ibig sabihin, mataas concentration niya. Dito yung pumapasok yung Beer's law sa mga photometers. So, basically, ang ginagawa ng photometer ay it measures the light properties. And based on the light properties, you can quantify your objects or your chemicals. Hindi lang quantify, you can also identify them. Okay? So, pwede mo ma-identify yung mga elements na nandun. Pwede mo ma-measure gano'n sila karami using photometers. Okay? So, since we are dealing with light, there are many modes of interaction ng light with matter, such as absorption, emission, and fluorescence. So, I hope na na-discuss to ng maigi sa lab, sa lecture, kasi dadaanan din natin siya later. Okay? So, if you want to watch my video on this, nasa YouTube na rin. Section 1 yung title. Okay? So, yan. Ayun lang. Daanan natin uli yan mamaya. When you say spectrograph naman, so from the word itself, graph, ibig sabihin this is a picture, So this is a graph, picture of ano meaning ng spectro? Light, So this is a graph showing the different wavelengths of light, And alam nyo ba na for each element, there is a unique spectrograph, And that was actually observed by Niels Bohr, Okay, so kay Niels Bohr, in-investigate niya that for each elements daw, may corresponding silang mga spectrograph. No? And from that, na-discover nila na yung atomic structure ay different from what they thought before. And nag-develop sila ng sandamukal na mathematical data, no, to further understand the atoms, no. So ito yung ginawa ni Niels Bohr. Sabi ni Niels Bohr, each atom will give us different spectra. Okay? Iba-iba yung spectra na ibibigay nila because of their different properties, no. Iba-iba kasi yung atomic properties nila, such as the number of orbitals, the energy levels of those orbitals, no. So all those things play a role, no, in determining the spectrograph of the atoms, no. Okay, so yan, by comparing them we can identify anong elements meron tayo in our sample. Okay, another term would be the spectrometer. Okay, so spectrometer, so ano yan? That is a metering device used to measure light, no? So parang similar yung mga terms nila, no? Yes. Kaya sometimes we interchange them na lang, no? Kasi similar naman sila ng concept lahat eh. Okay, so kapag spectrometer, this is a device used to measure the interaction of light, no? Para siyang ano kanina, para siyang tawag doon, para siyang photometer din. But for spectrometer, ang ganap lang dito is that take note of the italicized word, may monochromator. Ano yung meaning ng monochromator? Chroma meaning colors, no? Mono ibig sabihin one. So when we have a monochromator, that means we are observing a single color. Okay? Or to be specific, we are going to observe single wavelengths, no? Remember that for each color, there is a corresponding wavelength, di ba? So, ayan. Ganyan yung gagawin natin kapag spectrometer. Pag photometer, halo-halo yung kulay. Pero, kapag spectrometer, we are just observing a single wavelength, no? And its interaction with our matter. Pag sinabi namang spectrophotometer, okay, so nadagdagan yung word natin. So, ito rin yun. Spectrometer lang din yan. But, in this time, when we have a spectrometer, we are equipped with what's called a phototransducer. When we say phototransducer, these are mechanical devices that converts light into electrical energy. And this actually uses the concept of photoelectric effect, no? That concept gave Einstein his Nobel Prize, no? So, pasensya na, wala ako sa iPad ngayon eh. Naka-mouse lang ako. So, kapag sinabi nating phototransducer, it makes use of the concept of nawala tuloy. Ano yung sinabi ko? It makes use of the photoelectric effect, no? Pasensya na, wala ako sa iPad, ha? Nag-charge eh. Photoelectric effect. Ito yung nagbigay kay Einstein ng Nobel Prize niya. Not the theory of relativity. Okay, hindi yung theory of relativity. Because the theory of relativity was just confirmed recently, no? Almost decades, no? After Einstein died, no? Doon lang siya napatunayan. Doon sa picture ng black hole last year. Do you still remember that? Around April yun, no? Pinost, no? Ayun. So that is a visual proof that Einstein was correct. No? Okay. Ayan. So anyway, so pag sinabing photoelectric effect, ano meaning niyan, no? So daanan ko lang siya slightly kasi physics to. Okay. Okay. So for example, you have the phototransducer here. May metal yan, no? May metal yung phototransducer. Then, syempre, di ba, may light tayong ginagamit dito. When the light hits the phototransducer, ano mangyayari? Nagkakaroon ng photoelectric effect. Ano meaning nun? Yung light, pag tumama siya sa metal, yung electrons ng metal tatalsik. Okay? Tatalsik yung electron niya to the electrode, no? So, kumbaga, nagkakaroon dito ng circuit, no? Kasi, remember, sa ating discussion sa electrochem, yung gumagalaw lang naman is electrons, kaya nagkakakuryente. Ganon din dito, no? So, mangyayari, ide-detect ng ating spectrophotometer kung may tumatamang light doon sa sensor natin. Okay? And when the sensor detects na may light nga, tatalsik yung electron niya. And when that electron goes to the other electrodes, doon nagkakaroon ng circuit. Kaya nga sabi natin dito, it converts light energy to electrical energy. Pag tumama yung light dito, tatalsik electron, so magkakaroon ng circuit, aka may kuryente. Yan yung ginagawa sa spectrophotometer. No? So depending on the intensity of the light energy that hits the phototransducer, depending kung marami yan or onti yan, we can tell kung ano yung concentration ng ating substance. No? Para siyang Nernst equation. No? Kasi sa Nernst, di ba, voltage and concentration. This time naman, hindi siya technically Nernst, no? Pero analogous lang. Kasi this time we are using light, no? So, depending on the intensity of the light, you can tell the concentration of your substances. Okay? So, ayun. So, dito na tayo gumagamit ng Beer's Law, A equals epsilon BC, no? So, ang mini-measure na to is the absorbance in reality. And you can convert absorbance into concentration using the Beer's Law. Okay? So, let's go back and let's have a short review of the types of spectroscopy, no? Spectroscopic processes that happens in our matter, no? So, ano ba yung nangyayari when our light interacts with matter, no? So, there are three modes, no, na pwede mangyari. We could have emission, we could have absorption, and we can have photoluminescence. Okay? So, isa-isahin lang natin just to have a short review. Okay? So, when we say emission spectroscopy, what happens here is that this is your analyte, this is your sample. So, this is your sample. What will happen here is that you will add energy to it, no? So, pag naglagay ka daw ng energy sa kanya, magliliwanag siya. Okay? So, totoo ba yun? Is it real? No? Yes. Because, for example, initin nyo yung bakal. What will happen when the metal was heated? It glows, di ba? Nagkukulay siya. Ganon din nangyayari sa atoms. No? So, kapag yung atom mo, initin mo yan, it will glow. The light emitted, you can measure the light emitted, no, using emission spectroscopy. Okay? So, depending on the amount of light emitted, you can quantify gaano karaming atoms meron dyan. Okay? So, ito yung ginamit ko sa thesis ko in the form of AAS, no? Atomic Absorption Spectroscopy or Atomic Emission Spectroscopy. Okay? So, ganun ginawa ko doon. Sinunog ko yung aking sample. Nag-glow siya. Kulay green. And then, yan. Pwede mo ma-measure gaano siya karami doon. Okay? You may ask siguro, no? Bakit nga ba sila nagliliwanag? No? Actually, that was a very good question before, no? Around early 19th century. Kasi ang physicists dati, no? They can't find a way to explain why matter glows, no? When heated, no? And isa nga ito sa mga foundation of the quantum mechanics, no? Yung physics and chemistry na maraming math, no? Yun yung inaaral ko ngayon, kaya nakakaiyak. Okay. So, yun yung isa sa mga foundation ng quantum mechanics, no? Yung bakit sila lumiliwanag. Ang explanation doon ni Niels Bohr as the father of quantum chemistry or quantum physics, quantum mechanics. So, siya kasi yung isa sa mga nagtaguyod noon. Actually, kinalaban niya si Einstein. Si Einstein, di siya naniniwala sa quantum mechanics. Si Niels Bohr, naniniwala siya sa quantum mechanics. Napatunayan natin na totoo yung sinasabi ni Niels Bohr. Wala, talo si Einstein. Ano lang lesson doon? Hindi porket matalino ka, always correct ka. No? Yun. Kasi even Einstein was proven wrong by Niels Bohr. Okay. So anyway, so bakit nga ba nag-glow daw yung matter? Ganito kasi yung explanation ni Niels Bohr. Diba remember, his atomic model was orbital, no? Planetary model. So, electron occupies certain orbit, although alam natin hindi talaga ganun. Pero just to simplify, let's assume na ganun yung case. So, suppose we have an electron here. Ayan. Pasensya na uli. Medyo pangit yung aking illustrations today. So yan, for suppose this is an electron, if we add energy onto it, no, in the form of heat, no, kunwari initin mo yan, ano mangyayari? Ano nangyayari? 'Di ba na-excite yung mga particles, no, kapag may energy, may heat, no? Gumibilis yung galaw nila. So as a result, the atom will go up to a higher energy level. Okay? And then after nun, babalik ulit siya sa baba. Okay, so magjo-jump yung ating electron from lower energy level to high energy level and then babalik uli siya pababa. By the time the electron relaxes, ibig sabihin, babalik na siya sa original energy level niya, it releases light, no? Okay. So, ganun yung konsepto dito. Kaya kailangan initin mo yung matter mo so that it will emit light. Okay? Ito yung explanation ni Niels Bohr. When you add energy to your particles, the electrons will literally jump from one energy level to another. And then babalik uli yun sa original. And as it goes back to the original energy level, it releases light. Okay? Hindi naniniwala si Einstein dyan, pero totoo yan. Okay? Yan yung inaaral namin ngayon eh. Okay? So yan. So, ayan ha. Yun. So, yan lang. So, that's emission spectroscopy. How about absorption spectroscopy? Pag sinabi ng mga absorption spectroscopy, from the word itself, absorb. No? Ibig sabihin, energy is being absorbed. No? Medyo similar siya sa illustration natin kanina. Okay? So, Niels Bohr pa rin tayo. So these are the electron orbitals. Suppose we have electron here. Kapag light energy ang nilagay mo dyan, what will happen is that the electron will jump from one energy level to another energy level. May excite lang siya. So may excite lang yung electron from one energy level into another energy level. Okay. So yun lang, walang relaxation. Excite lang. Okay. Dito kasi may relaxation kaya nag-emit ng light. Dito naman excite lang. Okay. So what happens kapag na-excite yun, no? Papansin nyo, yung energy nagagamit to make the electrons excited, no? So ibig sabihin nun, onti na lang yung tatagos na light when it passes through the sample. Kasi nga, some of that light energy is used to excite the electrons. No? So as a result, onti na lang yung tatagos doon. Okay? So ginagawa natin dito is that we compare the transmitted radiation or the transmitted light. Hindi ko makita kung nasan yung cursor ko. So, ginagawa natin, we compare the transmitted light and the incident light. Pag kinuha mo negative log niyan, you will get what's called the absorbance. Ito yung sa Beer's law. Okay? So, ito yung nangyayari doon. Iko-compare mo lang gano'ng karami yung tumagos sa incident na. Known yung incident. Yung tumagos, di natin sure kung gano'ng karami. Okay? So, by comparing that, yung ratio nito and ito, i-negative log mo lang, okay, you will get the absorbance. And what we know according to Beer's law is that the absorbance is proportional to the path length, which is B, and C is the concentration. So that means if mataas yung ating concentration, mataas yung ating absorbance. Ibig sabihin, maraming sample ka doon. Okay. Sandamukal yung sample mo, edi onti na lang yung tatagos doon sa kanya. No? Imagine translucent films. No? Compare mo yun sa transparent. No? So imagine nyo yung translucent films, it absorbs the light. Okay? Ayun. So, parang ganun lang yung idea. It absorbs light. So, ibig sabihin, unti na lang yung tatagos sa kanya. Compare mo yan sa transparent na lahat tatagos. Okay? So, yan. So, ibig sabihin, the more substances we have, no, the lower the transmitted radiation will be. Therefore, malaki yung ating absorbance. Marami siyang ina-absorb na light. And yun, we can use the Beer's law to get the concentration of that. Pwede mo yung pwede mo yan i-linear regression. I hope na alam nyo na how to do linear regression. So, sa aking lecture class, pinakita ko yung calculus method and the Excel method. No? So, you can make a linear graph, no, to know the concentration when the absorbance is given. Ayan. So, ito yung commonly ginagamit sa lab. No? Gagamitin nyo rin to once na nag-work na kayo. Okay? Kasi apparently, ito talaga yung ginagamit din sa medtech field, yung absorption spectroscopy. Okay? So, next one, we have the photoluminescence spectroscopy. Okay? So, basically, ano lang to? Magkahalo na yung emission pati absorption. Okay. So, when we say luminescence, these are objects, no, or chemicals that glow when the electrons are excited. Isang example niyan would be the glow stick, which we use nung bata pa tayo. Okay. So, I remember when I was grade 1 pa, no? 2000, kailan ba ako nag-grade 1? 2004. 2004, grade 1 ako. Ayun, bumibili-bili pa ako niyang glow stick na yan. No? 5 piso lang yan dati. So, ayun, babaliin mo yan, di ba? Tapos mag-glow na siya. Okay? So, nangyayari doon is that due to chemical reactions or external energy sources, doon, nag-glow yung ating matter. No? Okay? Kaya siya lumiliwanag. Siyempre, pag gabi, doon na siya liliwanag talaga. Okay? Kasi pag umaga, hindi mo makikita. No? So, yan. That's the photoluminescence. We can actually use that property para wait lang yan. May nag-text lang. So, we can use the property of light na yan para ma-quantify yung ating matter. Okay? So, yan. Ganun lang din. You can use Beer-Lambert's law. Okay, so yun. And now, let's talk about the instrument we use. No? Let's talk about the spectrophotometers. No? How do they look like inside ba? Okay. So to give you an idea, ito yung itsura nila sa labas. No? So let's take a look at UV vis. Okay. So ito yung itsura niya sa labas. We have this thing called the UV vis spectrophotometer. Ito yung luma namin. Ito yung luma na ginagamit ko sa PUP dati. No? Nung undergrad ako, syempre PUP ako. So, luma yung gamit namin. Ito yung gamit namin. No? Tapos, bumili sila nito. Ayan. Kung kailan kami gagraduate na, doon lang bumili ng bago. Di ba? Pero ayan. So, ano yung nasa loob niyan, no? So, pag ginamit nyo kasi ito sa, sa work nyo, ganito lang din itsura niyan sa loob. O, ayan. Ganyan lang din itsura niyan. Okay? Ang gusto natin malaman is ano yung nasa loob niya, no? Para mas maunawaan natin yung mga processes that happens inside. Okay? So again, gagamit kayo nito pag nag-work kayo sa laboratory, no? Okay? Or even academe, gagamitin nyo yan. Okay? So let's talk about the components of the spectrophotometers. So number one, for absorption spectroscopy, this is how things inside look. Ganito yung itsura niya sa loob. No? You have the source, you have the wavelength selector, you have the sample, detector. All of them are linear. No? Okay. Kaya minsan pahaba sila. No? Minsan pahaba sila. Naka-linear yan. Ayan, naka-straight line yan lahat. No? Yung mga components na yan. For example, ito, ang haba. No? Yan. Yan, mahaba, di ba? Kasi yung mga components niya ay naka-linear yung fashion. Okay? So, yan. Okay, pag-usapan natin yung mga nangyayari. Okay. So, on the leftmost side, dito yung light source mo. Okay. So, ano yung light source? Okay. Basically, mga lamp yan. Special lamps, no? And what we know about lamp is that they produce all forms of wavelength, no? For example, itong liwanag ng aking lamp, no? Desk lamp. Okay? Halo-halo kulay dyan. Meron niyang red, mayroon niyang orange, may yellow, may green, blue, violet, no? Halo-halo yung colors dyan, no? Kasi alam natin, yung white light ay combination of all colors, di ba? However, sabi nga natin, since ito ay spectrophotometer, no? Spectrometer to, we are going to choose a certain wavelength only, no? So that means we have to use a wavelength selector. Kumbaga, if we have a spectrum of light, kailangan pauntiin mo. Yan. Gawin mong isang wavelength lang. Okay? So we use the wavelength selector for that. And once we selected the appropriate wavelength for our analysis, dadaan nyo ng sample. Okay? And dito sa sample, doon na mangyayari yung absorption. And syempre, mas onti na yung transmitted kaysa sa incident. Yung detector mo, i-compare niya yung dalawang yan. And the instrument will read that as absorbance. Okay? Siguro you may ask, no? How will you determine ba the wavelength na kailangan ko gamitin when doing chemical analysis, no? Or spectrophotometric analysis. Okay. Remember, ito, hopefully na-discuss to sa lecture. Remember your color wheel. Okay. Nagagamit pa rin natin yung color wheel dito. Hindi lang siya ginagawa noong kinder. Hanggang ngayon, gagamitin natin yan. Okay. So, yan. 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 So, we have this color wheel. Very simplified color wheel. So, alam natin in physics is that yung nakikita nating light yung nakikita nating color ng object, yung complementary nun, yun yung ina-absorb niya. Okay? For example, di ba yung plant, kulay green yon kasi it reflects green light, no? Pero ang ina-absorb niya is the complementary color of that, no? So kung green yung ating plants, ibig sabihin it absorbs red color. So ibig sabihin kung ang sample mo ay kulay green, ang wavelength na pipiliin mo ay yung kulay red, which is around 600 to 500. Okay? 500 nanometers. 600 to 500 nanometers. I'm not really sure kung ano exact numbers. I think 700 nanometer to 600 nanometer. Basta gan, may table dun sa lecture. Andun yung mga correct wavelengths. Okay? Hindi ko kinakabisado yun eh. But yun yung idea. Okay, kunwari, kulay green sample mo, edi you choose the wavelength that is the complementary of that, no? Which is red. Yun yung itatype mo dito sa wavelength selector. Nakaprogram na yan. Okay? So, ipoprogram mo yan sa instrument. O, kunwari, you have a kulay blue na solution. You have copper sulfate, kulay blue yon. According to this graph, the blue, ang complementary niya ay orange, di ba? Ibig sabihin nun, kapag blue yung color niya, it will absorb orange colors. So, we will choose wavelengths that fall under this category. Okay, the correct wavelengths are given in your lecture table. Please check na lang. Kunwari, you have a red color solution. For example, that's iron thiocyanate. Kapag kulay red yung solution mo, edi ang wavelength na pipiliin mo ay yung kulay green. Doon mo makikita yung lambda max. No? Familiar pa ba kayo with the lambda max? Nasa lecture yan. Diba? If you run the experiment, ganito yung graph niyan, diba? And the lambda max tells you the absorbed color. No? Absorbed color. Ayan. So, for example, kunwari, kulay yellow yan. Ang makikita mo, ang i-absorb niya ay violet color. Okay? Doon mo makikita yung lambda max sa violet wavelength. Okay? So, ganun lang yung idea. Okay, so, since alam niyo na pumili ng wavelength selector, pagbasihan mo lang yung kulay, then choose the complementary color. Yan, dadaan na yan. Kasi absorb niya yung kulay na yan. Okay? And then the detector will compare the incident and the transmitted light and makukuha mo na yung absorbance. For fluorescence spectroscopy, same diagram. However, the source and the selector are perpendicular with the detector and the selector as well. So perpendicular siya. Why does it have to be a perpendicular? Ba't sila kailangan perpendicular to one another? Kasi ganito. Remember, fluoresce, ibig sabihin, liliwanag yan. By the way, kung naniniwala pa rin kayo na si Filipino na fluoresce yung gumawa ng fluorescent bulb, mali yun, ha? Malaking joke time yan. So, hindi si Flores yung gumawa ng bumbilya. Joke lang nila yan. Okay, so anyway, so for fluorescence, remember that when you hit your sample with light, it glows, no? Okay? So, nag-glow yun. Okay. Or you do chemical reactions with it, mag-glow yun, di ba? Okay. So, ang mangyayari kasi, kapag dito mo nilagay yung iyong source, mangyayari is that, mag-a-add up yung light nila. Di ba, may light to, tapos ito, may light pa yan, mag-a-add up, no? So, magiging times 2 yung light, no? Halos times 2. So, to prevent that from happening, kasi hindi naman ito yung inaaral mo, ito, no? So, kailangan naka-perpendicular siya, no? So, kailangan naka-perpendicular yung ating wavelength selector. Okay? Ay, sorry. Ay, naka-perpendicular yung source natin. Kasi nga, pag di siya naka-perpendicular, mag-a-add up yung light nila. Okay. Pag naka-perpendicular, at least, yung liwanag lang nito yung ma-observe niya talaga. Okay? Kasi this one is out of the view. Wala siya sa view. Okay? So you can also notice that there are two wavelength selectors here. Dito sa source, then before the detector. Okay, bakit? Kasi nga, ang gagawin natin dito, we're going to excite the molecules here at a certain wavelength. Okay? And then, kapag nag-glow yon, halo-halong kulay lang din ibibigay niya. Okay? Halo-halong kulay ibibigay niya. So, you want to limit the wavelength as well. Kung ano yung wavelength na nilagay mo doon, kailangan yung ma-detect niya is yung wavelength din na yon. We should remove the other colors. Okay? Kaya dalawa yung wavelength selector. Ayan. Take note that for fluorescence spectroscopy, the detector and the source are perpendicular to one another, and then there are two wavelength selectors. No? Okay. For the reason na yung ating sample, mag-glow yan. So, it will emit many colors again. So, kailangan mo siya i-filter. For emission spectroscopy, ganito yung itsura. You have your source somewhere here sa left. Then, you have your wavelength selector, detector, and your sample. Ano yung difference niya? Yung wavelength selector, hindi siya sa tabi ng source. Nasa tabi siya ng detector. Bakit? Kasi dito sa emission, literally, sinusunog mo yung matter mo. And we know that flames produce many wavelengths. No? Halo-halo yung kulay doon. No? May kulay blue, may kulay orange, di ba? Kapag nakikita nyo yung kandila, ganun yung color niya. May blue, may orange. No? So, kung i-filter mo yung wavelength before mo siya sunugin, edi nonsense, no? Kasi maghahalo-halo lang din color. So, gagawin mo dapat, the wavelength selector should be placed before the detector, no? Para maghalo-halo man yung kulay na yan, okay lang yan, no? Kasi pagdating dito, dun mo lang siya i-filter. Okay? And by the way, literal na sinusunog yung particles dito. Okay? So, you have your liquid solution, lulublob mo yung nozzle. Yun, susunugin niya yun doon. Ito yung ginamit ko sa thesis ko. No? When I quantified lead sa solution, lead is a toxic metal. Yan. So, yan. Pag nag-glow yung lead, kulay green siya. No? Ayan. So, ganito yung idea dyan. And so, you have your sample here. YouTube pala yan. Ito. So, you have your sample here. Susunugin niya yan dyan. Yan. And you have your incident light here. Okay. So, the incident light will also help us to excite the electrons. To excite the electrons further. Okay. So, yan. Then, saka mo lang isa-select yung desired wavelength mo. For metals, there is a corresponding wavelength for each metal. No? Okay. So, that can be given by Niels Bohr yung spectra niya. Okay. So, yun din yung ginagamit namin until now. Okay. So, yun lang. Again, take note that for absorption, yung wavelength selector ay katabi ng source and they are all linear. Okay. Pag fluorescence, perpendicular, dalawa yung wavelength selector kasi yung ating sample lumiliwanag. Okay. Pag emission, yung wavelength selector before the detector siya. Kasi nga, susunugin mo yung sample, it will emit multiple colors. No? So, saka mo na siya i-filter. And then, always ang output niyan ay absorbance, no? Or intensity. Okay? So, yun yung mga output niyan. Absorbance o kaya intensity. So, the materials to be used in spectrophotometry or spectroscopy are different depending on the type of analysis you're doing. Okay? So, iba-iba yung materials na gagamitin natin. Because some materials do interact with light as well. So, kapag yung material mo nag-interact with light, it could cause errors in your measurement. Okay? Pwede lumaki standard deviation mo o kaya karoon ka ng outliers, which we don't like, di ba? So, for each type of analysis, there should be a corresponding material to be used. No? May proper material na kailangan na gamitin. Okay? So, ang common na ginagamit namin, for example, for UV-Vis analysis, we use the quartz. No? Okay. Quartz ginagamit namin dyan. Okay. So, ito yung itsura ng quartz na yan. So, this is the quartz cuvette. This is a glass, special glass that is used for UV analysis, no? Although hindi lang yan yung hindi lang yan yung pwede. Marami pa, no? Okay. Pag nabasag nyo to, medyo mahal to. Okay. Kasi may nangyari sa amin. Before kami graduate, mayroong nakabasag niyan. Since mahal siya, tinulungan na lang din namin. As in, super mahal niyan eh. Meron pala sa Lazada. Hindi pa kasi uso Lazada noon, no? 2018 yun eh. Ba't mura dito? Fake yan. Fake to. Ako na nagsasabi. Kasi ang quartz ay super mahal. 5 digits yun eh. 5 digits yun nabili namin. Okay. So yun. May 5, merong 4, pero ang concept kasi sa chemistry, pag mas mahal, better. Kaya ganun. Kaya yung mga instrument na binibili sa chem is mga milyones, kalahating milyon, yan. Kasi better yung kanilang results. So yan. So if you're doing UV analysis, you're going to use quartz, no? Okay. Then kapag ibang type of analysis naman, for example, IR. Okay, so for example, you have your IR. Kapag IR naman, ang gagamitin mo is yung mga ano na, salts, NaCl, KBr, AgCl, okay, or the KRS, tellurium bromide, and tellurium iodide. No? So ginagamit madalas kapag IR analysis is the KBr plate. Okay, so this is how it looks like. Yan. So para siyang ano, ayan, hindi ko ma-explain. Alam niyo yung ano, contact lens bago siya hulmahin. Ganyan yung itsura niya. Yung contact lens kasi before siya maging curve, ganito muna siya. Parang ganito lang din yan. Okay? So yan, so you will place your sample here, iipitin mo yan. Then you will analyze it in the IR. No? So for every type of analysis, there is a corresponding material that needs to be used. Bakit? Kasi nga, ano, pwede mag-interfere yung ating atoms ng materials with the with different wavelengths, no. Okay? So para better yung quality ng ating result. Okay? So now, balik ulit tayo sa mga sa mga components. Let's talk about the light source. So for light source, maraming uri ng light source, no? The common one is the tungsten filament. Basically, parang ito yung mga bumbilya, no? Mga lumang bumbilya. Okay. So for tungsten filament lamp, you have your tungsten filament. Yun yung tawag doon, or yung bakal ng tungsten, naka-flip, naka-flip dyan, no? Then, ang gagawin niyan is that, pag pinadaan mo yan sa kuryente, liliwanag yan. So, pwede mo na to gawing light source. But again, since it produces many wavelengths, you have to filter it using monochromator. Okay? So, yan. The wavelength range of the tungsten filament is from 320 to 2,500 nanometers. So, this is good when you are doing UV and visible analysis. Actually, pwede rin siya sa hindi. Okay. So, ano siya? UV and visible analysis. Doon siya okay. I think IR, medyo hindi na. No? But, since ang problem with tungsten filament lamp is that, napapansin nyo sa mga bumbilya dati, mabilis mapunde. Okay. So, ganito din to, mabilis mapunde. No? So, they improved that. So, they added iodine, the halogen, at tinawag nila yung tungsten halogen lamp, no? Or THL, no? So dito sa tungsten halogen lamp, you still have the same tungsten material pero may halogen sa loob, no? Before kasi ito ay vacuum, walang air dyan. Kasi kapag may air dyan, the oxygen in the air can react with the metal, no? So masisira yan talaga. Pero if you replace the air with halogen, for example, iodine gas, then it will prolong its lifetime, no? So, mas matagal yung kanyang buhay, hindi agad siya nasisira. And also, the addition of iodine increased the operating temperature of the material from 3,500 Kelvin. From 3,000 Kelvin, ngayon 3,500 Kelvin siya. And we know that at higher temperature, the brighter the color will be, no? Kaya ayun, mas better to. Okay. So ito yung ginagamit sa UV-vis then. Okay. Deuterium lamp, from the word itself, deuterium, ibig sabihin, it contains hydrogen gas but in the form of deuterium. Okay. So, pwedeng hydrogen gas din naman. Pero ang ginagamit is deuterium, the isotope of hydrogen. Okay? So, this is commonly used when you are doing UV spectroscopy. UV lang, ultraviolet lang yung kaya niya. Okay? For other analysis such as HPLC, high-powered liquid chromatography, we will discuss this next meeting. Okay? I mean sa asynchronous session. Okay. So ito naman, it uses mercury arc lamp. So basically, you have your mercury gas here. Pag kinuryente mo yan, liliwanag yung mercury gas. Okay. So I think this is also used in UV. Okay, UV analysis. Next one, we have the hollow cathode lamp or HCl. HCl din tawag namin dito. So basically, for hollow cathode lamp, we use this for emission analysis or absorption analysis ng metals. No? Okay. So ganito yung itsura nun. Medyo mabigat to. Nakahawak na ako ng ganito sa Lasal. Inside this ay yung vapor ng metals. No? May metal vapor sa loob niyan. And syempre, kapag kinuryente mo yon, it will glow. Okay? So mag-glow yan sa wavelength ng metal. Okay, so typically yung AAS or yung AES, atomic absorption or atomic emission spectrophotometer, maraming lamp yun. No? So may lamp yan for nickel, may lamp yan for magnesium, may lamp yan for lead, zinc, copper, iron. No? So iba-iba yung lamp niya kasi nga specific dapat yung wavelength for the metals. Etong nasa picture si Ryan, busted na yung light niya na. Hindi ko lang kung ba't yan yung nilagay nila. Pero sira na yung lamp na yan. Yan. Okay. So next type of the light source for for infrared spectrum, we use the glow bar. Okay. Para lang tong lapis, no? Yung lapis or the carbon rod, pag ininit mo yun, magkukulay red yun, di ba? It will emit infrared rays. Ganun din yung glow bar, no? It will emit infrared rays, no? Or mga reddish color. But this time, since hindi siya carbon rod, glow bar siya. So, pinaghalong yan, silicon and carbon. Silicon carbide. So, pinaghalong yan yon, then it will heat up to 1500 degrees Celsius and it will emit infrared rays. No? This is what we use in IR spectroscopy. The other thing is the Nernst glower. This is also used in IR spectroscopy. Ang component naman niya is zirconium and yttrium oxide. Okay, so it operates at higher temperature. Ibig sabihin, better yan. However, mas mahal yan. Okay? So you are using rare elements such as yttrium and zirconium. No? Mga nasa dulo yan ng periodic table, kaya mahal yan. No? Yan. So in summary, these are the light sources and these are the type of spectroscopic analysis that they are good to use. No? Yan. So marami pa yan. No? Actually, sandamukal yan. Pero onti lang yung nilagay namin dito. Kasi nga, hindi naman tayo BS Chem. Okay. So yan. So remember that for UV analysis, ito yung mga pwede mong gamitin. For IR analysis, ito. Yung higher wavelengths. Okay. So yan. So tapos na tayo sa light source. Now let's go to our wavelength selector, also called monochromator. Okay. So monochromator, from the word itself, chroma meaning light, colors. Mono ibig sabihin isa. So from the spectrum of light, you are going to choose only one. No? Ang gagamitin mo doon ay monochromator. Okay? Kunwari, kung gusto mo multiple light wavelengths, no? So you use the polychromator, but the commonly used one in instruments are called the monochromators. No? So gagawin na to from the spectrum of light, saselect niya lang yung iisang color. Okay? So paano to gumagana? So it works like a prism, no? Parang prism lang yan. Remember, yung prism, pag yung white light pinatamaan mo doon, lalabas yung rainbow. Okay? So, ganun din ginagawa nito, no? Okay? So, ganito yung isang general idea for monochromator. So, you have your light source here. Then, it will use a prism, no, to split the light into several colors. Then, it will only choose specific color, no? Okay? So, let me zoom in. Ayan. So, this is your incident light. This is the prism. Gagawin niya, pipiliin niya lang yung iisang color dyan. Okay? So, kunwari, you chose 500 nanometers. Then, it will choose, yellow-green color. Okay? Kunwari, nilagay mo is, 400 nanometer. Medyo violet yung pipiliin niya doon. Okay? So, ganun lang yung idea for monochromator. Okay? Ito yung old style, no. Yan yung lumang style. But what we use now are gratings, no. So instead of using prism, we use gratings, no. So gratings, para siyang ganito. Let me zoom in. May mga pangil yan, no. So that when light passes through those pangil-pangil, no, ma-split siya into many colors, no. When the incident light passes through the grating, mag-split yan into many colors. One example of material we use at home which has gratings are CDs, no. Yung CDs natin, may grating yan, no. May mga pangil-pangil yan sa loob, no. Maliliit nga lang. Kaya nga sensitive yung side na to, no. Hindi mo siya pwede scratch kasi kapag na-scratch mo yan, masisira yung grating and as a result, di nagagana yung CD. Putol-putol na. Okay? So, yan. So, yan. The reason bakit siya nagko-colorful ganyan-ganyan dahil yan sa grating. Compare nyo yung CD na blank sa CD na may something na nakasulat doon. Yung CD na may nakasulat doon is yun yung may gratings. Yung CD na blank is walang gratings yan. Okay? So, bakit may gratings doon? Yung laser yung dahilan, no? So, nila-laser yun para magka-gratings and as a result, may store yung data. Hopefully, alam nyo pa yung CD, no? Okay. Kasi ako, lumaki ako sa CD burn dati, no? Nung kabataan pa. Actually, magkakaedad lang tayo halos. 1998 lang naman. Pero yun nga, idea. Kung hindi kayo familiar with the CD, baka masyadong advanced na yung generation niya. At pare-pares lang tayong Gen Z. Okay. Dati kasi nagpapa-CD burn ako, no? Kaya tinitignan ko talaga yung CD. Pupunta ka sa com shop, pa-CD burn nga po nito. Ayan. Tapos papatugtog mo siya sa bahay. Ngayon kasi may na tayo, Apple Music na, no? May Spotify. Pero dati yan, no? So yun, you can actually use the CD, no? You can actually use a CD to be your wavelength selector. Okay? My professor in chemistry, Sir CJ, yan yung kanyang master thesis, no? Gumawa siya ng low-cost spectrophotometer. Ang ginamit niyang wavelength selector ay CD. Okay. And effective naman, maganda yung study niya. Kaya nung undergrad namin, gumagawa kami ng mga ganito-ganito, no? Ayan, nakaka-enjoy din. Okay, so yun lang yung idea sa grating, no? May mga chop-chop yun sa may mga chop-chop siya. And then when the light passes through that, ma-split sila into different wavelengths. Kaya nagko-color rainbow. Okay, so ayan. Skip na natin yung iba. Ganun lang naman din yung concept. Okay. So sometimes, we also need filters, no? Okay, filters are needed, especially kunwari yan ay emission spectrophotometry. Kunwari lang. We use filters, no? Bakit na? To further minimize the other light sources, no? To minimize the stray light from entering our detector. Parang lang din to, parang kunwari ma-microscope kayo, 'di ba? Sometimes we use filter in microscope, 'di ba? Sa ilalim nun may fini-flip tayong filter, no? Kasi sometimes kapag white light yan, di mo makikita yung organism. Pero kapag nilagyan mo ng filter na kunwari kulay blue, dun mo makikita yung shape ng organism, di ba? Sa medtech, gagamitin nyo yan kasi alam nyo na, ganun yung gagawin nyo sa buhay. Okay. So, gumagamit kami ng filter then sometimes to further minimize interferences from the environment, especially the stray light. No? When I say stray light, yun yung ilaw sa paligid. No? Okay. Ayan. So, we use filter to remove them from the analysis. Okay. So, ayan. This is one example of the filters, absorption filters. No? So, ginagamit siya for absorption analysis. Kunwari, you are doing IR analysis naman. Okay. Sa IR analysis, ang possible sources ng interferences could be the analyst itself. No? Himself, herself. Okay. So, yung analyst mismo, pwedeng maging source ng error yan. Bakit? Kasi remember, sabi ko sa lecture ko, tayo mismo, nag-glow tayo. No? We are literally glowing because according to physics, basta mainit yung object, may wavelength yan. And apparently tayo, mainit tayo, 37 degrees Celsius tayo at normal temp, diba? So we are also emitting wavelength, no, in the form of IR, infrared rays. Kaya nga kapag nagta-thermal scanner tayo, nakikita natin yung mukha natin nagkukulay pula. Kasi we are literally glowing. No? Kasi mainit tayo eh. Okay? Yan yung concept ng black body, no, sa physics. No? Basta mainit yung object, it will glow. No? Okay? So parang tayo din. Kaya gumagana yung thermometers. Ayun, thermal scanners pala. Okay. So yun yung problem with IR analysis. Since we are also releasing infrared rays, no, we have to filter that using interferometer. So interferometers are filters used in IR analysis or IR spectroscopy. Later, kwento ko kung ano meaning ng IR spectroscopy. Basta yung IR doon ay infrared na. So yan. So when you use IR spectrometers, gagawin yan, it will scan the environment. No? Kailangan kapag nag-scan ka, nakatayo ka lang doon steady. Okay? Kasi i-scan niya yung buong paligid ng kwarto. Tas sobrang lamig pa nun, no? To minimize the infrared rays. No? Kaya pag nag-scan ka niyan sa isang room, mga 5 minutes yan siguro eh. Nakatayo ka lang, lalamigin ka na lang kasi super lamig dapat ng room. Ayan. Tapos after doing that, then you can start analyzing na. Okay? So, yan. So, babasahin niya kasi yung infrared rays sa paligid to remove that from the measurement. Okay. Ayan, so we're okay na with wavelength selectors. Meron na tayong light source, meron na tayong filters. Now we proceed with the detectors. Okay. So from the word itself, no, detector, yun yung nagde-detect ng ng light. Okay. And typically, no, for spectrophotometers, we use a transducer as a detector. Okay. So yung transducer, ito ay detector which is ang ginagawa niya is from light energy, it converts it to electrical energy. Okay? Convert niya yung light energy into electrical signals which can be processed by computers. No? Yung computer naman, gumagana yan by signals. No? 1010 lang yan. Okay? So, yun. So, para maintindihan ng computer ano nangyayari sa paligid, yung transducer, ko-convert niya yung physical data into bits of data, 1010 or kuryente. Okay? So these are the many types of detectors we use in spectrophotometry. So we have the photon detectors. So when you say photon detectors, ito yung ginagamit sa mga UV-vis analysis, no? Ultraviolet visible analysis. Pag thermal detectors naman, ito yung mga ginagamit for IR spectroscopy. Kasi remember, infrared rays ay form of heat, no? Kaya thermal detectors tawag doon. Okay? So ito yung mga ginagamit sa IR spectroscopy. So punta muna tayo dito sa photon detectors, mga nagde-detect ng light. Ito yung focus natin today. phototube. Okay, so phototube, this is a tube that determines the amount of photons that hits it. No? So kumbaga, at the end of the spectrometer, you will have this. No? Ito yung diagram na. Okay. Suppose kunwari itong red ball pen ko gamit yung mouse. Ito yung light. No, ito na yung transmitted light. So it will hit the metal here. The metal is the cathode. Then, according to physics, according to Einstein, when the light hits the metal, it undergoes what's called the photoelectric basta yun, effect. Ayan, ito pala, dito yun. Yan. So when light hits the metal, it undergoes through a process called the photoelectric effect. Yun, dinescribe ko kanina. Pag tumama yung metal doon, ay yung light doon, yung electrons ay tatalsik. No? So, tatama yung light, tatalsik yung electron. And since tumalsik yung electron, the circuit is complete. And with that, yung light energy na-convert to electrical signal. Okay? So, kapag maraming light energy yung tumama niyan, ibig sabihin, maraming transmitted light. So, mababa absorbance. Kung onti lang yung light na tumagos dyan, ibig sabihin, mataas yung absorbance. Okay? So, ganun niya ini-interpret yan. So, depende kung super dami or super onti lang yung light na tumama dyan, it can tell us the absorbance using the equation negative log P over P naught. Okay, so that is a phototube. No? So, it has a metal, curved metal, it has electrodes. Pag tumama yung light, tatalsik yung electron, so magkakaroon ng kuryente. And that can be translated into absorbance. Para siyang para siyang electrochem. Sa electrochem naman, yung ions i-detect niya, I mean yung voltage i-detect niya to determine the ions. Ito naman, yung voltage, nire-relate niya sa absorbance. Okay? So, nire-relate niya sa absorbance yung voltage. So, the improved version of phototube is called the photomultiplier tube or the PMT. Basically, it has the same concept. However, mas marami yung iyong cathode. Mas marami itong metal curves na yan. So, mangyayari dyan, since marami kang metal curves dyan, when the incident light passes through it, pag tumama yan dyan, magbabounce, bounce, bounce yan. Kaya nga sinabi multiplier kasi nai-increase yung sensitivity ng instrument. Kasi yung light, magbabounce, bounce, bounce siya sa loob. No? Okay? So, mas sensitive to. Okay? Kasi it can multiply the amount of light hitting through the cathodes. The other improved version is called the photoconductive cell. So instead of using metals, we use semiconductors. This is a similar idea with solar panels. Ano ba nangyari sa solar panel? So nangyari sa solar panels that pag may semiconductor ka, you have a positive terminal and a negative terminal. Kunwari, ito yung light. Gawin nating yellow para kunwari, sunlight. So when the sun, kita ba? So when the sun hits the electron on the surface of the solar panel, ano mangyayari? The electron will be excited. Pero since nasa positive siya, gagawin niya, babalik siya sa negative. Okay? So tatalon siya doon, then babalik siya sa baba. And if that continues to happen, may kuryente ka. Okay? So ito yung nangyayari sa solar panels. Ganito yung ginagawa dito sa photoconductive cells. No? So basically, you will have your life. Asan yung cursor ko? Okay, so mangyari dyan, you will have a light that will hit that semiconductor there. So ito yung mga semiconductor, lead sulfide, mercury, cadmium telluride. Pag tumama yung light dyan, yung electrons, yan, magpo-flow siya. So ibig sabihin, na-convert niya yung light energy to electrical energy. Similar yun dito, no? Pero this one is much advanced, no? Okay. And this is proven to be much more sensitive than phototubes, no? Medyo similar siya with the photomultiplier. Ito, hindi na siya gumagamit ng photoelectric effect, no? So it has something to do with the properties of semiconductor, wherein meron tayong N-type or P-type semiconductors na hindi na natin i-discuss, no? Okay. Basta yung nangyayari lang doon, electron tatalong lang, tapos iikot lang siya uli. So kapag paikot-ikot yung electron doon, may kuryente. Yun yung nangyayari sa solar panels natin. Then we also have photodiodes, no? So this is somehow familiar with every one of us, no? Bakit, no? Kasi kapag tinignan nyo yung camera nyo sa cellphone, may mga photodiodes yon. Okay? Pakita ko sa inyo sa iPhone 12. Hanapin ko yung sa iPhone photosensor. So yung mga photosensor natin is actually a photodiode. Okay. Ayan. So yan, makikita mo yung square na yan. Yung square na yan, ha. Ito yun eh. Ayan yun, no. Ayan. So nangyayari, kung paano nakakuha ng picture yung ating cellphones, no, gagawin yan, it will collect the light, no. So the bigger the photodiode is, the greater the amount of light it can absorb. Kaya palaki ng palaki yung camera ng iPhone, di ba? Dati maliit lang yan eh. Tapos ngayon ang lalaki na, di ba? Tapos tatlo pa. So ang purpose nun, the bigger the sensor is, the more light it can absorb, therefore the better quality. Okay? So ganun din ginagawa dito, no, sa ating spectrophotometry. Yung light na matatransmit ng sample natin, tatama siya dyan sa photosensor natin or the photodiodes, no. And then it will be converted to electrical current, no. Electrical signal. So ganun din sa cellphone natin pag nagpi-picture tayo. Yung light, tatama yan sa mga photosensors dito, and then yung computer, it will interpret it as an image, no. Okay? So kaya ganun. Diba? Ito yung maganda pag chemistry, no. Dami mo na i-explain. related lahat ng mga bagay-bagay sa chem. Okay? So semiconductor din yung process dito, no. Semiconduction. Okay? So, similar with the previous one, no, photoconductive cell. So yan. So kung meron kayong digital single lens camera, okay. Kung may mga digital single lens camera kayo, baklasin niyo yung lens, no. Diba? Napapalitan naman 'yon. Makikita niyo meron kang photosensor. That is actually a photodiode, no. So doon tumatama yung light. Then nako-convert yon into images using computers. Okay? For IR naman, instead of using light detector, we used thermal detectors, no? Okay. So it determines the heat from the surroundings naman. So ito yung mga lens ng ng thermal camera. So hindi ganito yung lens ng thermal camera, instead ganito yung lens niya. So yung light energy from the surroundings, tatama dyan, and as a result, it will be converted to image, no? May mga nasa thermal scanner natin. Okay? So yun. Okay, so take note of those stuff, ha? May mga similarities and may subtle differences, no? But the idea is that they will collect the data, either that's light or heat, ko-collect nila yon. Then, i-convert nila into electrical signals which will be translated to absorbance or intensity. So now, punta tayo sa sample. Paano mo nilalagay yung sample doon? Lalagay mo ba siya sa beaker? Hindi. No? So, when analyzing sample, especially in UV spectroscopy, we use a cuvette. No? Cuvette basa dyan, or cells. No? Dito, yung letter B sa Beer's Law. No? Okay. Remember Beer's Law, A equals epsilon BC. Yung B, this is the size of your cuvette. No? Typically, the size of cuvette is 1 centimeter. Kaya papansin nyo sa solving sa lecture, 1 centimeter gamit. No? Okay. But there are versions of cuvette that are much smaller. Meron din namang much wider. No? Okay. So ito yung iba't ibang uri ng cuvette. And take note that they should be made in silica or quartz. No? Kasi kung hindi sila gawa sa quartz, medyo pangit yung quality ng makukuha mong light. No? Kasi kunwari, plastic yan. Although we use plastic then, pero that is not really advised, especially kapag research ka. Pero pag ano lang, tamang assignment lang yan. Plastic cuvette gamit namin. Pero yun nga, yung plastics, no, it can interact with lights, no, especially UV. Kaya pangit yung magiging result mo nun. Better kung quartz gamitin mo. So maraming uri ng cuvette. Iba-iba yung shape niyan, pero ito yung common na ginagamit namin. For other purposes, we use other types of cuvettes. Meron cylindrical. Meron ganito. Meron ganyan. Okay. So I'm not really familiar with the others kasi di ko sila nakikita. Ito kasi yung common na ginagamit talaga. No? Okay. So pag nag-work kayo sa lab, ganito rin naman gagamitin nyo. Okay. Okay. So yan. So with all those components, we can create what's called our instruments. No? Okay. So pag pinagsama-sama mo yung mga components na yun, mga detector, light source, monochromator, filter, yung mga cuvette, no? And then the detectors, then you can have what's called the spectrophotometer. No? Okay. So let's check yung UV-vis na sinasabi ko, ultraviolet visible spectrophotometer. So yan, typically we have tungsten lamp, no? Take note na yung wavelength range niya is 322 to 500 nanometer. So pwede siya sa UV-vis. So you have the tungsten lamp, so liliwanag yan, and then yung light na yan, it will be sorted to wavelengths, no? To certain wavelengths. No? Tapos kapag nakapag-choose na siya ng isang wavelength, then yun, papadaan niya yun sa sample. And then, yun, sa sample, gagawin nun, i-detect ng detector sa dulo yung gano'n na lang karaming tumagos sa sample, then makuha niya yung absorbance reading. Okay? So, ganun lang yung idea. Ito na ano na natin to kanina, di ba? So, anyway. Nakakwentuhan na natin to kanina. Ito na lang, and nilagyan niya yung application. So for UV-vis, we use spectrophotometer for photometers. This is sometimes used for chromatography, electrophoresis, immunoassay, and continuous flow analysis. So sa electrophoresis, ito yung ginagamit for sequencing of amino acids, no. Pag nag-biochem kayo, madadaanan niyo uli yan, electrophoresis. So this is used to sequence amino acids, no? So, ang graph niyan ay ganito. Basta pag ganyan-ganyan yung graph niyan. So, each line will correspond to a certain amino acid fragment. Yan. Basta sa biochem, dadaanan nyo uli yan. Okay? So, the old version of UV-vis ay single beam lang. So, it is a very long tube na isang beam lang yung kanyang nilalabas. Ito example, ito yung itsura nun. So single beam, so mahaba yung mga single beam na UV-vis, no? Kasi isang straight line lang ngayon lahat, no? Yung source, dire-diretso yan sa filter or monochromator, reference to your detector. Ang problem with single beam is ganito. Kunwari, maglalagay ka reference mo. Usually, ang reference ay solvent, no? Tapos, kunwari, mag-analyze ka na, papalitan mo to. Okay. So, every time nagagamit ka, papalit-palitan mo yan. Okay. So, medyo nakakatamad yon, especially if you're doing many samples. No? So, ayaw mo yung paulit-ulit ka magpapalit. No? So, ginagawa namin is that instead of using single beam, we use the double beam. No? So, ang double beam, this is a better version of UV-vis. No? So, marami siyang pwedeng i-analyze. Okay. Kasi yung nangyayari doon, bakit siya naging double beam? Yung incident light mo, it will be split into two. The first one will go to the reference and the other one will go to the sample. So that, kung ikaw magre-read ka ng magre-read ka ng sample mo, hindi mo na kailangan pag-switchin tong dalawa. Kasi meron silang corresponding compartments, no? So, typically, itong sample cell na to ay naka-carousel yan. Let me show yung carousel. So, ganito itsura ng carousel na yan. Teka lang. Zoom na lang natin. And so, yan, ikot-ikot na lang dyan yung cell mo. So, dun yung reference. Ang nilalagay sa reference, again, take note, water lang o kaya solvent. Kunwari, hexane gamit mo, lagay ka hexane doon. Kunwari, water ginamit mo, hindi water lalagay mo doon. Nasa cubet pa rin, ha? Tapos dito sa sample compartment, yan, ikot-ikot na lang siya. Okay? Hindi mo na siya kailangan palitan every now and then. Okay? And that minimizes the error in measurement na. So better ang accuracy kapag ganyan, or I mean better ang precision. Okay? So yan yung kagandahan for double beam. The beam is split into two. One will go to the reference, the other will go to the sample. Then dito na siya magko-compare ng incident and the transmitted. And then makukuha mo na yung absorbance. Double beam in time, same concept lang din, but I'm not really familiar with this one kasi hindi ko nagagamit to. I don't know kung ginagamit talaga to ng iba, no? Pero yeah, sa research industry ginagamit to. Nangyayari lang dito is that you have something here, may motor ka, that will, magro-rotate yan, ikot-ikot yan. Okay. So, may time na ito bukas, ito bukas, ito bukas, ito bukas, no? Okay. So, ganun yung nangyayari dito. Paikot-ikot tong mirror. So, nagsiswitching yung ating wavelengths. I'm not really sure kung anong application niya. Pero the common one in industry is this one, the double beam. Mas mabilis yan. So, wala pang wala pang 10 seconds tapos ka na sa analysis. Ayan. Okay, let's talk about IR very quick, no? IR spectrophotometer, saan to ginagamit, no? So, sa UVVs, yun ay ginagamit for identifying the concentration of substances, no? So, dun siya ginagamit sa pag-identify ng concentration ng substances, and you can use the Beer's law. For IR spectrophotometry naman, hindi siya ginagamit for quantifying. Rather, it is used to determine the qualities of your sample. Inaalam natin yung mga components ng sample. For example, does it have carbonyl groups? Does it have hydroxyl groups? No? Meron ba yung double bonds? May triple bonds ba yan? Okay. So basically, itong IR spectrophotometer, ginagamit namin to identify kung anong bonds meron sa isang sample. So for example, you have this sample. Ayan. You have this compound. Hindi ko yung papangalanan kasi di ko alam pangalan. Nanghula lang ako ng compound. Kunwari, you have this sample. Gagawin mo, papatama mo yun ng infrared rays. No? Ano ba nangyayari when infrared rays hit the molecules? Ganito. Nagva-vibrate yan. So, nagva-vibrate yung bonds. No? And the detector for IR spectrophotometers can actually detect those vibrations. Kaya nila i-detect yung vibration na yan. For example, nag-vibrate yung mga double band, lalabas yan dito. For example, ito. Ito, CH2 stretch. No? Ibig sabihin, naggaganong-ganon yung double band na yan. Nag-stretching siya. For example, you have this carbonyl group. No? Pag yung carbonyl nag-vibrate yan, may peak yan. Carbonyl stretch. Ayan. Apparently, wala tong hydroxyl. No? Dito kasi yung hydroxyl. Pero wala. Okay. So yun ang idea, no? So IR spectrophotometers are not used to quantify. Rather, this is used to identify the functional groups in your molecules, especially organic molecules. And ito yung ginagamit namin to identify kung anong type ng molecule yun nandyan sa sample mo. No? Kung yan ba ay glucose, yan ba ay cellulose, yan ba ay ano, kung ano-anong compound. No? So yan. So yan. Yan yung spectrophotometer. Let me share yung aking graph nung nag-thesis ako. Asan ba yan? Ito, matagal na tong PowerPoint na to. Proposal pala to. Yung final defense ng thesis ko, pakita ko na lang. Ayan. So, hindi ako magde-defend ha. Ayan. So, we use the infrared spectrophotometers to identify the functional groups in our molecules. Okay. For example, we have acrylamide. So, pag nag-vibrate yung mga bonds na yan, you can detect it. When this amine group vibrates, may ganito siyang peak. When this carbonyl group vibrates, may ganung peak. And then, itong mga nasa dulo, that is the other vibrations of those molecules. For example, we have this cross-linked polyacrylamide. So, na-minimize yung NH vibration kasi na umonte yung bonds nila. Ayan. Umigsi yung intensity na itong carbonyl groups kasi nagamit sila for bonding, so on so forth na yan. For glucose, may OH yan, so makikita mo yung OH stretching dyan. Ayan. And the C single bond O stretch then. Okay, so for glucose polyacrylamide, maghahalo yung OH stretch and the NH2 stretch. Ayan. So yan yung ginagamit namin sa chemistry, no? Yan yung ginagamit namin to identify anong mga molecules meron dyan sa iyong sample, no? So yan yung ginamit ko sa thesis ko. Basta yan. Ayan. So yan yung aking idea sa thesis. Okay, so yan. In the future, you will be using them, no? So, skip ko na to kasi hindi naman natin di-discuss masyado yung IR. Pero this is how it looks like, no? Ganyan yung itsura niyan. The Fourier transform IR, this is an improved version. So it uses multiple mirrors to make the instrument much more sensitive to different wavelengths, no? Okay? So yan. So saan to ginagamit, no? So hindi lang to sa chemistry ginagamit. Even biology gumagamit nito, ano? Apparently mas gamit pa nga to ng biologist kaysa sa amin, eh. Okay. Even in medical field, no? So suppose you are creating drug design, no, for specific enzymes. To check their enzyme activity, then you have to use UVVs, no? Yung classmate ko, ang study ng thesis niya ay enzyme activity. So gumamit siya ng UVVs, then makita niya yung wavelength ng enzyme niya. So yun, makita niya nagbabago-bago. Ibig sabihin, the enzyme is functioning. Okay? So yan. So hindi lang doon yung nagagamit, you can also use this to quantify nucleic acids, no? Kung gusto mo malaman yung mga DNA dyan sa sample mo, yung protein sa sample mo, ginagamit din to. Okay, so yan. So this is used in variety of applications. Kaya yan. You will use this. So for now, I know medyo blurred pa yung idea na to, no? Because ganun talaga eh, online tayo eh. Wala kayong on-hand experience on how to use this. No? Pero in the future, no, hopefully after a while, pag tapos na yung pandemic, hopefully makagamit kayo nito in your higher courses, no. Kasi this is useful pagdating sa industry, no. Kapag nag-work kayo sa companies in the future, gagamit kayo ng mga spectrophotometers, no. Yan. Kaya inaaral natin yung concept. Okay? And yeah, so that will be all for our last synchronous session. Okay? So again, takeaways lang bago tayo mag-end ng session. Ano yung idea dito? There are three types of spectro uh, there are three types of spectrophotometric analysis: emission, absorption, and photoluminescence. So take note of the difference lang sa tatlo. Kapag absorption, linear yan. Kapag fluorescence, perpendicular. Kapag emission ay ang wavelength selector before siya ng detector. Okay? So these are the lamps we use, no? So be familiar kung kailan sila gagamitin, ano yung improvements, and sino yung mga ginagamit for IR. For ano naman, for wavelength selector, basically mga grating lang yan. Okay. One example of grating is yung mga nasa CD. For detectors or transducers, we have phototubes, photomultiplier tubes. Yan. So, yeah. And so, paano yung ganap ng quiz natin dito? Your quiz here will be multiple choice. Minsan may free response question tayo. So, yan, minsan may matching type. So, ganun mangyayari sa atin, ha? Pagdating sa quiz natin. Okay? So, yun lang. You will have a break from calculation kasi this topic is just concepts, no? Okay. So, yan. Hindi nyo naman kailangan kabisaduhin, no? Pero, you need to be familiar with the subtle difference of each. No? Okay? And with that, no? So, we're done with chapter 6. No? Do you have any question about our chapter or we're good to go na? Okay, so I think we're okay na, no? Sige. So, ganun lang, puro concept lang tayo, ha? Okay, so that will be all for our last day, no? So again, next week ay ano na tayo? Next week ay hindi to sa inyo. Next week ay asynchronous na tayo. So good luck with your quiz 6 muna. That will be due tonight. Okay. And then quiz 7 will be uploaded by the weekends na lang. So sa weekend ko na lang siya i-upload, no? Together with the video for the last discussion. Okay? So take note of your schedule very well. Dahil malapit na yung Hell Week nyo. Actually, Hell Week naman every day. Araw-araw naman tayo nasa impyerno. So, sanay na tayo na. Pero yun, be minded na malapit na yung final exam nyo. Kaya you really have to utilize your time very well, ha? Okay? So, take note of this calendar. I-upload ko yung quiz dito. Okay? So, yun lang, no? So, with that, no? Maybe okay na tayo for the session. Okay, so thank you for being with me for a short period of time dun sa mga students ko before dito. So thank you for being with me for a year, no? So it's been a pleasure to be with all of you. Okay. Next year, iba na yung chemistry instructor nyo kasi biochemistry yon. And yun ako makikita doon. No? So, sina Sir James na bahala sa inyo doon. Okay. So, also, ano pala, in case na mag battery exam, remind ko lang na gagawa ako sa YouTube ko ng review classes doon, no. Gagawa ako ng mga review sessions doon. Mga 5 to 10 minutes sessions, no. Review siya ng inorg-chem, org-chem, anachem, no. Na hopefully magamit niyo pag nag-battery exam kayo in the future. Okay? So, ayan. So, you can still ask me questions even di ko na kayo students, no? Because apparently, yung mga student ko last year, nagtatanong pa rin sila sa akin until now. Okay. So, yun lang. Do not hesitate to ask me questions even though na hindi ko na kayo estudyante. Okay? So, I'll be very glad if you will ask. No? Okay. So, yun lang. Thank you again for being with me for a short period of time. No? So I'll see you again next time and hopefully face to face. Yeah. So ingat po parate and goodbye. Bye-bye. Okay. So a copy of the class recording will be uploaded on YouTube.